Hi, welcome to another pre-calculus mini lecture. Today's topic is using cofunction identities. So first let me go ahead and explain this critical word identities before we get to the rest of the discussion, which is very easy. Identities themselves are a heart of trigonometry and a section that's quite rich and interesting. Let's see if we understand what the issue is before we get into details. When you come to mathematics, there are certain terminology that we need to use carefully. One of these is, identity, something that comes up in the list, but first we perhaps need to know what's an expression. Then we need to know what is an equation. And after that, we come to issue of identity. What's an expression? So suppose I write 2x plus 3. Sometimes you refer to it as a formula. So you have some variables like this x here. You do certain operations on them like doubling and then adding a result to it and so on. There is no sense of equality or comparison of this with something else. Equation, however, we do make a comparison. So suppose I have x plus 2 is equal to, say, 5x plus 10. Here, the implicit statement is to go ahead and look for an x that makes two sides equal to each other. So we are looking for some x. So the question is, what is x that makes this thing to be true? So you learn in algebra how to go about this. Sometimes you come across something like this. X plus 1 squared is equal to x squared plus 2x plus 1. What we are saying here is the sense in which this equality is written here is different from that one. In the last one, what we are saying is that the two sides equal to each other regardless of what x is. So sometimes we say this is always true regardless of what x is, because if I take left hand side x plus 1 and multiply it by x plus 1, what I get x times x is x squared, 1 times x, and another 1 times x, and 1 times 1. And when we boil it down, we get x squared plus 2x plus 1, which is exactly what is written on the right hand side. So what is on the right hand side is essentially another reincarnation of what is on the left hand side. We are not looking for a certain x, rather we are saying these two are always equal. It's the identity in this sense that is very significant in trigonometry, and now we are going to start with one of the simplest example of this. Now, what is meant by cofunction? So what's a cofunction? This is specific to trigonometry. In trigonometry, you know, remember we had 6 functions that we were studying. So we had, let's consider this angle, say theta, in this angle alpha, and write this thing as A, and say this is, or let's write this one as A, this one as B, and this one as C. So these 6 functions, we can break them apart into 2 lists and pair them up so that the pairs of functions are considered cofunctions of each other in the following sense. Suppose I go ahead and look at sine of the angle theta. Well, what is that? Sine is the ratio of, let me clean this up. Sine is ratio of opposite to to the hypotenuse. Well, what is cosine of alpha. Cosine of alpha is the ratio of adjacent to hypotenuse, which is the same thing. Well, what is cosine of theta? Cosine of theta is the ratio of adjacent to hypotenuse. Well, what is sine of alpha? Ratio of its opposite to hypotenuse, which is the same thing. How about tangent of theta? Tangent of theta is the ratio of adjacent to, ratio of opposite to adjacent. Well, what is cotangent of alpha? Ratio of its adjacent to its opposite. How about the other way around? Cotangent of theta is ratio of its adjacent to its opposite, and that is same as tangent of alpha, which is the ratio of its opposite to its adjacent. Similarly, if you come across, say, secant of theta is the ratio of hypotenuse to the adjacent, and that is same as what? It's same as cosecant of alpha, which is the ratio of hypotenuse to the opposite. Same way, cosecant of theta is same as hypotenuse to the opposite, and that is same as secant of alpha, which is the hypotenuse divided by the adjacent. So you notice an angle and 90 degrees minus that angle share the same sine and cosine. So here what we have is that if you take the angle theta and alpha, if you add them up, you get 90 degrees, or you get pi over 2 radians. Is that right? If you add these two, you get either 90 degrees or pi over 2 radians. So what happens is that the sine and cosine of these two turn out to be the same. You can look at the sine of this and the cosine of the other one, or cosine of the first one and the sine of the second one. So sine and cosine make a cofunction pair. In the same way, tangent and cotangent make cofunction pair, and similarly secant and cosecant make another pair of cofunction pair. And what we are saying here is that the cofunctions of complementary angles are equal. So here we say theta and alpha are complementary, and what we get here is that the relationship between pair of cofunctions at a pair of complementary angles. Let's go ahead and practice this. So what is cosine of pi over 10 equal to? So it's not asking us for a number, it's asking for an expression that is same as this. So what do? First we say what is the cofunction of cosine. Cosine goes of course with sine. And what's the complementary angle of pi over 10? So we say what should I add? Let's write it like this. What should I add to pi over 10 plus what, so that I get pi over 2. So if it's in radians, we all look for an answer in radians. So say x is pi over 2 minus pi over 10. You take a common denominator, which is 10. So this becomes 5 pi and minus pi. So it becomes 4 pi over 10. You can leave it like that, or you can simplify it 2 pi fifth. It's the same way, but let's just leave it like that. 4 pi tenth cosine of pi tenth is same as sine of 4 pi over 10. Let's try another one. How about tangent of 2 pi over 5? So what is the cofunction of tangent? Well, it's cotangent. And how about the angle? We say pi over 2 minus 2 pi over 5. Again, we take a common denominator. This becomes what? 5 pi minus, and this becomes 4 pi, and then this becomes pi over 10. Okay, you notice what happened? So I have to multiply numerator and denominator of this by 5 to make the same denominator. Multiply numerator and denominator of this thing by 2 to make the denominator be 10. And numerators become 5 pi minus 4 pi, and the answer becomes cotangent of pi over 10. Similarly, we handle any other kind of problem in this section. So it's very simple. How about cosecant? What is a cofunction of cosecant? Well, it's just secant. Now, how about this one? This one is given in degrees, so our job is a bit simpler. 90 minus 50, and of course that is 75 degrees, so 75 degrees, and then we are all done. What's the cofunction of secant? Well, of course, it's cosecant. Again, 90 minus 66, what is that? 20, is that right? 24 degrees, am I right? 24 degrees. And that's it. How about cotangent? Well, the cofunction is tangent, and the angle is, well, 15 degrees. We are going to see these angles later on often, but how about sine? Final example, sine. Cofunction is, of course, cosine. How about the angle? So this time we have to do in radians, 5 pi over 12. Common denominator is 12. I have to multiply this thing by 6 for denominators to be same. 6 pi minus 5 pi, it becomes pi over 12. So pi over 12 is my answer. And I guess that's the last example I have here. So we had the example of each of these things. So the real issue here is getting used to identities. There are about 6 dozen identities in basic trigonometry. They're all significant. It might look a little bit overwhelming or rather dry at the beginning, but every single one of these things that you see here in this course is going to be used sometime down the line. Sometimes you have to wait a year or two until they actually show up. So here we are classifying all of them under one umbrella and going to go through these things in quick succession. And you might be wondering, well, what are we going to do with these things? Well, you have to wait a little bit until you see the applications. Before we close, let me say it's not just 90 degrees or pi over 2 that makes this statement to be true, but if theta plus alpha is coterminal with these angles, it is still true. So let me just state this thing before going. If theta plus alpha is any multiple of full circle plus 90 degrees, or any multiple of 2 pi plus pi over 2, same principle is going to be true. We are going to look at that more extensively later on. Okay, so in short, what did we find out? Cofunctions of complementary angles are equal. Complementary means the sum is 90 degrees or pi over 2. Cofunction means these pairs. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. If we take any element of this pair, apply to any of these angles, is going to be equal to the other element applied to the other angle. And that constitutes our cofunction identities. Okay, until next time, good luck and God bless.